A machine can be anything which can help us to do some work and which can make our work easier, faster and effortless. It is a device which helps us to lift heavy loads, speed up the motion and change the direction of force in the desired direction. Load, effort, mechanical advantage, velocity ratio, work input, work output, efficiency and some of the technical terms used when we talk about machines. A simple machine is a basis device that alters the magnitude and the direction of the force. Some examples of the simple machines are lever, inclined planes and pulleys. A lever is one of the most common type of a simple machine we use. It is a rigid bar which can be rotated and fixed point. A lever are used everywhere for door handles and for seesaw, scissors, punching machine and more. We will learn detail about machines and related technical terms and about some simple machines like levers in this particular lectures. Hi everyone, welcome to Study with Akshay and this is Akshay. In this particular video, as I have told, we will be learning about machines, technical terms and levers. So this makes the first unit or the first set of our machines chapter. So over here, before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notification. For extra support, please do contact the contact number given in the description window. So let's get started. Machines. What is this machine? Basically, a machine is a device by which we can either overcome a large resistive force or load at the same point of application of a small force or effect at a convenient point in a desired direction, or by which we can obtain the gain in speed. Okay, so this is the definition of machine and this is the cut shorted version of the definition which is given in your textbook. So please don't miss any of the terms which are given in this definition. Each term plays an important role. If you miss any of the terms, it changes the meaning completely. Okay, so principle of machine. When energy is supplied to a machine by applying the effort, it does some work or some useful work, to be more specific. So this is the principle. The point at which the energy is supplied to a machine by applying the effort is called the effort point. They might ask you define effort points or what is effort point. The point at which the energy is supplied or where the effort is applied, then that point is called as effort point. The point at which the energy is obtained to overcome the load is called a load point. Okay, so what is load point? It is the point at which the energy is obtained to overcome the load. So input energy is equal to work done at the effort point, or input energy is given by one more term, work done at the effort point, that is effort into displacement of point of application of effort. Okay, so this is not commonly given in your book. Okay, so this is an extra information, and moreover this information plays a very important role in solving the numericals problems based on this concept. Output energy, the work done at load point, is equal to load into displacement of the point of application of load. Okay, so what is ideal machine and actual machine? What is load and effort? I'll come to later. Okay, since the order has been changed, I will be moving ahead to it later. An ideal machine is that in which there is no loss of energy in any manner. Ideal machine is that there is no loss of energy in any manner. An actual machine is that the output energy is always less than the input energy. Like a teacher teaches you with complete knowledge, teaches you with complete portions. Okay, how much you can take, that is called as output, and how much you can reproduce while writing it on paper, that is called as output energy. How much you can take is known as an input energy. It is not ever possible that you take complete things and you reproduce complete things. Then in that case you will be an ideal case. You're taking completely all the details, all the information is given by the teacher, and you are reproducing the complete as such on your paper answer scripts. In that case, what happens? You will be scoring out of out, right? In that case, you are an ideal case. If you are not able to get out of out, in that case, it is an actual case, because you are not reproducing the complete thing whatever you have taken. Okay. What is the reason for this? The moving parts are neither weightless or smooth. So this is like a simple pendulum. Simple pendulum is like that bob. Okay, that bob should be weightless itself, and there is no substance. A matter is something which has weight and occupies space, right? So there is no substance without any weight. So it's like a simple pendulum. Here also, the moving part is neither weightless or smooth to make it an ideal machine. There is no machine which is ideal. Okay, the string in it, if any, is not perfectly inelastic. Okay, the different parts are not perfectly rigid. So if it is not perfectly rigid, then it must be elastic in nature. It should be inelastic also. So how is it so? So this is all with the ideal machine and actual machine. Ideal machine will not be present practically. Practically it is not possible to have an ideal machine, but theoretically we can have it via definition. Any machine in which there is no loss of energy. Energy can be lost in the form of frictions. Okay, so in that case it will become an actual machine. Okay, next. Technical terms associated with this. Load. It is a resistive or opposing force to overcome by the machine is called a load. Okay, so it is expressed by the letter capital L. So the expression matters a lot, because as and when we move further onto this chapter, expressions play an important role over here. And then effort, it is the force applied on a machine to overcome the load. Okay, it is the force applied on a machine to overcome the load is called an effort. Like you are cutting a paper and you are putting some effort over there on the scissor, right, in order to cut the paper. Okay, that is a simple example for this. What is mechanical advantage? It is indicated by MA. It is nothing but L by E I have written. What is L by E? It is the ratio of load to the effort is called the mechanical advantage. Okay, so I have just given the expression so that by just seeing the expression you can derive the definition. Okay, velocity ratio. Velocity of effort divided by the velocity of load, or it is also known as displacement of effort divided by the displacement of the load. Yeah, so velocity ratio, it is the velocity of effort to the velocity of load. It is the ratio basically, and or else in the other words it can be defined as the displacement of effort to the displacement of load. Okay, so here D refers to displacement of point of application of force or effort. DL refers to displacement of point of application of load. Work input. Work input is nothing but work done by the effort. Work output is work done by the load. Like I am cutting. Whether it is cutting or not, that is the work output. Okay. I am cutting, that is the work input. I am putting effort in order to cut the paper, that is the work input. And whether the paper is cutting or not, that is left over to work output. So efficiency, it is indicated by a symbol called as eta. Okay, so what is this eta? Eta is nothing but work input divided by work output. Right? So we can define this as efficiency of a machine is the ratio of work done by the load by the machine to the work done by the machine of the effort. Okay, so simple way, it is work output divided by the work input. go through this completely. Keep in mind the symbol for efficiency is known as eta. It's not N, it's eta. Okay, so let's move ahead further. Relationship between efficiency, that is eta, and the mechanical advantage, that is MA, and the velocity ratio, that is VR. What is the relationship? The mechanical advantage of a machine is equal to the product of efficiency and the velocity ratio. MA is equal to VR into eta. So, for an ideal machine, the mechanical advantage is numerically equal to the velocity ratio. In that case, the efficiency for an ideal machine is always 1. For an actual machine, the mechanical advantage is always less than its velocity ratio. So, the efficiency for an actual machine will always be less than 1. If it is equal to 1, then it is an ideal case. If it is less than 1, then it is an actual case. Then levers. It's not liver, it's levers. Okay. What are these levers? It is a rigid, straight or a bent bar which is capable of turning about a fixed axis. The axis about which the lever turns passes through a point of the lever, which is called as a fulcrum. Fulcrum is F. Like in a seesaw, we have something in the middle, and when two of you sits on the other side, so middle point where the pivoted point is known as a fulcrum. The pivoted point is known as the fulcrum. This point does not move but remains fixed. So only I have told it as pivoted when a lever is in use. So then, principle of lever. Moment of load about fulcrum is equal to moment of effort about fulcrum. On solving, we get mechanical advantage is equal to effort arm divided by the load arm. Okay, effort arm is from the distance between effort and fulcrum. Load arm is nothing but distance between load and the fulcrum. So this relation is known as the law of levers. This relation is known as the law of levers. So basically there are three kinds of levers. Class 1 lever, class 2 lever and class 3 lever. In class 1 lever, the mechanical advantage can have any value, either greater than 1, equal to 1 or less than 1. So for class 1 lever, the examples are seesaw, pair of scissors, crowbar, etc. are the class 1 levers. Okay. For class 2 levers, the mechanical advantage and the velocity ratio is always greater than 1. Okay. So for this, the example will be a nutcracker, bottle opener, and wheelbarrow, all those things. So these examples are given in your textbook itself. I am not taking the examples from anywhere else. It's from the textbook itself. So if you remember these things, that is more than sufficient. And class 3 levers, the mechanical advantage and the velocity ratio is always less than 1. For a class 3 lever, mechanical advantage and velocity ratio are always less than 1. Okay. So here we are done with the first part of the machine chapter. Still remaining 2 more parts are left over. So we will come with the next video. So if you have liked this video, please click on the thumbs up button. Please do share this video. If you have any doubts, any suggestions or any queries regarding any of the topics, not only machines or any other topics from your 10th ICSE, you can put it in the comment window, or we can have a discussion through a mail. You know the mail ID, right? studywithakshay65@gmail.com. Let's meet with the next video. Thank you and all the very best. Stay home, stay safe.